Okay, so there's a class called Arraylist. Arraylist was created within the Java language. It inherits from abstract. Let me write it. Let me write the inherited structure of it. It inherits from object. So object is the base. Every object in Java inherits originally from object, right? And then there's a class called abstract collection. Which is an abstract class, so you can't instantiate it, but that inherits from object, and that also comes with the Java language. And then there is a class that inherits from that called abstract list. Abstract list inherits from abstract collection, so that's also an abstract class. And then there's the class what we'll talk about is Arraylist. Now, this has a bunch of methods and data already built into it. And then there is also a, let's see, so Arraylist, this is its inheritance, and then it implements a number of interfaces. It implements a number of interfaces, and okay, so it implements clonable. Did cloning objects come up in your list? No? Okay, if you wanted to make an exact copy of an object you already have, you know how like when you say, when you have, if you say B equals A is something that you've already created, you've done a new operation and you've created an object A. When you do this, B doesn't become a copy of it. B is actually another reference to it. But if you wanted B to have its own copy of the data, to be its own thing, you'd end up doing something like a clone, called the clone function, and it makes a copy of it for B. So, okay. So, and then the only things that can be cloned are things that implement the cloneable interface. So there's a cloneable interface. Now, we've talked about interfaces. That's, an interface is a collection of methods, abstract methods, that if you declare that you implement it, you have to provide the bodies for those methods. So this abstract list class implements the clonable interface. Now, like we said about interfaces, you can implement many interfaces. You can only inherit once in Java, but you can implement unlimited interfaces. So it also implements a list interface. And it implements a few other random access. And it implements serializable. Which has to do with multi-threaded programming. So anyway, this class, Arraylist, implements many interfaces. So one thing we know is that it has to give the bodies to all the methods that are in these interfaces. That's the deal. When a class says, I implement this interface, you're required to give the bodies for it. Then there is an interface called a list. Interface called list. So what is an interface again? That was a collection of methods, abstract methods, that you have to go and implement the body of. This has the list has a super interface. Now, what's a super interface? So it's the same concept as inheritance, but an interface can inherit from another interface, meaning it will take in all those method bodies, and then it could add more onto it if it wanted to. So it has a super interface called collection. And then okay, so that's just a little background. So we're going to be talking about, just want to give an example of containers and then this concept of generics by using an array list. Now you might think, we already have arrays in Java. Why do we need this thing called an array list? Well, they decided, this came out, I think this came out around 2004. Java came out, I think, in 1995, around that time, but this concept came out, this idea of generics came out in 2004. They have a new type called array list, and it provides all the functions that you could use for an array, you know, checking the contents of the array, get the beginning, you know, add to the end. Functions that are commonly given were provided in this class. And the class implemented an interface called list. Okay, so suppose we wanted to do something like this. Suppose we wanted to make an array list. Okay. Do you think this would have a compiler error or not? So what I was just saying before, array list is a class. It's a class that implements an interface of type list. So could I create, now, an array list is basically going to operate like the arrays we're comfortable with. But there's going to be many more functions added that are going to be, good for us to use. It's like somebody else did all the work for us. Now what I'm going to do is I'm going to create a list and have it equal an array list. So this is just like the interface stuff we did before. We could use interface references of type list to refer to these items. Does that seem like there would be a compiler error for that or not? If list is an interface of array list, that array list implements. Okay, then we should be able to do, there's functions, like I say, you could look these functions up in a Java book or on Google, they're everywhere, but we could say, there'll be an add function, which is going to add an element to the list, and then we could say, okay, now, just what is the type of the elements in array list? Well, in its hierarchy, we saw it inherited from object, and then it went through a few things, and then eventually we got to array list. So what would its types be? Would these elements be integers, floats? Were they ever defined to be anything? What type would they be? They're going to end up being, for ease, they're going to end up being of type objects. So, can we put a string like test and store it into an object? So now what we have is we have a reference that is holding elements of type object, but a string is something that derives from object. So would this be a compiler error, like a type mismatch, or do you say, well, string inherits from object, so I'll store a string into an object, an object of type object, and allow this to happen. Now suppose somebody decided they wanted to go and get this value and return it into an integer. Suppose we wanted to have an integer equal, and let me just leave a little room in case we want to do a typecast. But suppose we wanted to say suppose we wanted to take the 0th element. So right now, what we have in our linked list, what we have in our array list, it originally started off empty, and then we added an element to it. So this got into location 0 of our array list. Now we're going to try to pull out the value. We're going to go to our, so what we end up having is we have an array, and it doesn't necessarily have to be like this, but I'm drawing it as an array for now. And this goes on. And the first element is text, is the string text. So this is an array list. This is what we're calling V. So this is actually a list. Every element in the list is of type object, but that gives us the ability to put anything that inherits from object, and the whole world inherits from object. Everything in Java inherits from object. So we could put the test string into the first element. That's what we did with this line. And now we're going to read the first element. So I'm going to call the get function. Like I say, these functions add and get. You can just look those up. But these are functions that this class, well no, actually no, this would have to be the list interface. It would be defined in the list interface. So the add function and the get function have to be defined in the list interface. And because Arraylist claims it implements the interface list, it must provide the bodies for these functions. So the class Arraylist provided the bodies for these functions, and these functions do appear in the interface list. So now we can call on V, we could say get the 0th element. This would be 0, 1, 2, and so on. We could say get the 0th element and return the string test. But could we do this? Could we say I wanted to this is a big I. Remember the big I and the whole word integer was the reference version of an integer? Right, it's not the primitive type int. It's an object that holds an integer, but it can be used as a reference. Would this compile? So would you let this compile, or would this compile but then have a runtime error? Like, what does this look like it would have to you? So, and if there was a compiler error or a runtime error, when would it happen? So the first step is saying, I have an array list, and I have an object of type, a reference V of type list. List is an interface. The array list does implement the list interface, therefore this should compile, this first line. We should be able to create an array list and refer to it as a list item. Could we then take the list item and call the add function, which is in the list interface and has been implemented by the array list class? The body of the add function has been supplied, so you can use it. Could we pass in as a parameter a string that says test? Is the type of V compatible with string? Well, the type of V is object, and everything inherits from object. So you would expect this to work. Now I'm going to get the first item. I'm getting the string out of the data structure. And I'm saying, well, what am I doing here? Right, I'm typecasting it to an integer. So now I'm trying to take a string and typecast it to an integer. Can you do that? Can you take a 4-character string and turn it into an integer? You can't. That'll have a compiler error. And then take the result and store it into an integer I. But would this, I'm sorry, I shouldn't have said compiler. This would be an error. There's something wrong with this. I'm trying to convert a string to an integer. Would this be a compiler error or would it be a runtime error? So what you're looking for now is, can the compiler look at this line and figure out there's no way this is going to work? I don't need to run this program. I can tell right now this will not work. If that's the case, it'll be a compiler error. But if it can figure it out, then it's going to blow up at runtime. So can the compiler figure out that V, calling get on the first item, would the compiler know that this item will not be an integer? Or something that can be typecast into an integer. Like this, if this was a float, we can typecast a float into an integer. But we can't typecast a string into an integer. But could the compiler figure out that this item will not be castable to an integer? Could it know it? And you might think, well, it could read up above and try to figure out the fact that the first add was a string, and then it should know that this item maps to that. But it wouldn't, the program could be very, very long with numbers and strings being added, and you can't keep track of which was the first one. There could be a for loop, and it doesn't know how many times, or a while loop, it doesn't know when the while loop broke. You could have, inserted 1,000 items into the list, and you don't know the 647th item, was that an integer? You don't know. So it really can't tell. So this would end up producing a runtime error. We compile this, if we try to compile this, it'll compile fine, and it'll have a runtime error. So we would prefer to be more defensive and have a compile time error. It's bad news when you have a runtime error because everything compiled, you think your product works, and then it runs, and you don't know why it's failing. So we could do something similar to this by supplying the type, and this is where this concept of generics comes in. We could supply the type by saying this. We could say list, and then we're going to do the less than sign and say string. V equals new array list. Okay, and then the same line would work. Well, what we're doing here is now we're saying, yes, this is a list, but it's a list, and up here the list is of type object, which means anything of type object or anything that inherits from object, which is really the whole world, can be stored in it. Now what we're doing is we're upgrading the type to string. So now it's a list of type strings. So all the functions are still the same that come with list, but the only thing we're going to accept is string, or anything that inherits from string will be acceptable. So now, if we tried to add a number, it would have a compiler error because we know only strings are acceptable. So this will compile fine. And now if we try to do the same thing we had before, we would have if we said if we had the same code, now, same exact code, same idea, but let's say the person creating this object, kind of knew these were supposed to be strings, and then a little bit later on lost track of it and tried to convert something to an integer and would have this runtime error. Now that we made it a little stronger, the typing of this a little bit stronger by saying these are strings, this line the compiler can now see this won't work because you're taking V, which is which is a list of strings, and trying to convert them to an integer, and the compiler knows you can't convert string to an integer. But this time the type was object. So we can generically say what the type, when we have something like an array list, which is basically a container class, it contains items of some other type. And a list is an interface, but it's references to objects of some other type. We can actually explicitly say what the type is. If we leave it out, it'll end up being object, which makes it very big. Very powerful, but very big. And then we can actually give the type if we want. We can generically change the type. So the array list and the list are actually generic types. They can be whatever. They could be containers that hold whatever type we want, and we can pass in the type that we want. Okay. Now suppose we wanted to make our own type. We wanted to make our own generic type. And suppose we decided to do something like this. Let me do this first. Let's say it's that here. First. Second. Okay, so I'm creating a class called pair. It's basically going to be, when we create one of these objects, there's going to be a pair of integers for now. So we'll be able, every integer will be paired up with some other integer. And we could create as many of these pair objects as we want. And we might have a method called get second, which returns the second. Okay. What other method might, a simple method that this might have? Return, yeah, like return both, I guess. Yeah, but what I want to do is what I'm trying to get at is, right now I'm doing it for integers, but I want it to be something that we might want to pair all different kinds of stuff, not just integers. So adding them together will only, yeah, maybe we could do an add. But adding strings together is different than adding numbers together. So let me do Well, let's do, since everything eventually will convert to a string, let's do this. Let's say public we'll do a toString method, which basically says return like the two strings there. Okay, so let's say we had, so whatever this pair of things are, right, you can always call toString on anything and it'll convert it into a string, right? That you remember from strings. So we can have a method called toString, and it'll convert the first thing, whatever it is, integer, float, string, it'll convert that into a string, and then put a dash, and then the second one convert that into a string. Okay, so now what we have is a class called pair that each item that you create when you create one of these is a pair of integers. So each item that you create ends up being a pair of integers. So if we created one of these objects, it would be a pair of integers. We could do a 3 and a 1, right? It's a pair of integers. We might want to have a class that is a pair, but we don't want, and we're going to write lots and lots of functions. Like get the first one, get the second one, convert it to a string, find the highest of the second values. You know, if we made a list of these items, find the highest of the first. We could make tons and tons and tons of methods. And then we'll say, oh, wouldn't it be nice if we had the same pair thing for floats? Right? So then we'd have to cut and paste the whole class, make another one, and then everywhere you see integer, you have to change it to float. That could end up being painful. And then you want to do it again for characters. And then you might want to have a pair of like student name and midterm grade. And that could be a pair. You know, whatever, first name and last name. There's so many different types of things that we could pair together, right? The concept of a pair is so vague, it's so generic, that we might want to be able to write a class in such a way that the type, like in this case I did integer, the type could really be anything we want. And that's what we want to be able to do. We want to be able to declare a class. This is generally if it's a container class. And the type of the item that the thing is containing can be whatever type you want. So, can you think of anything just off the top of your head, how we could, I want to get rid of the integers. I guess I need a, finish this class, I guess I need a first and a second field. And the fields are generally private, so I'll do this. Private integer first. And then close out the class. So, I have two private fields, first and second, also of type integer. I have a constructor method with the same name as the class. Takes in two parameters of type integer, f and s, copies those into our private fields. And then I have a bunch of methods. And like you could, as you can imagine, we can make hundreds of these methods. So whoever goes to use this pair object can use all of those methods. After we're done creating this pair class, which is exclusive for just integers. This only works for integers.
That would normally go on the top, right? Private.
Anyone have a comment about that? Like, what he's saying is these fields, the fields that are
Did you just
part
forget to put them in or now, or you just like?
well, what I wanted to do, I want to go over this whole class with a different color marker, and everywhere I see the word integer, I want to change it to something that's not integer. It's just, it means anything. But I realized that these fields were missing. But these fields don't have to be at the top.
Yeah,
They could be anywhere. I guess it's a thing of style, where you have your data could be at the top and your methods at the bottom or something like that. But anyway, after we completed this entire class, we said, wow, this is a great class. And like I said, we have 3 methods here. Pretend there's hundreds of methods that have something to do with a pair. All the things you can do with a pair. And then we decide, wow, this is a great class. Now I want to make the same class for floats. And when I'm done doing that, then I want to make the same class for strings. Then I might even want to, like I was saying, I might want to have string, the first one to be a string and the second one to be a number. It could be a student's name and a student's grade. And so all of a sudden you start thinking, wow, there's going to be lots and lots of combinations of the types for pairs. I'm going to have to do a cut and paste, and then I have to manually type in, everywhere I see integer, I want to manually type in something, you know,
Couldn't you like
float.
declare them? I don't know, I've never done it before. Could you like declare them to as something, and then instead of having to go through the whole code and change them individually, you can just change them to ones that you have declared on the top. You know what I'm saying?
I think you're kind of getting to it. So what I'm going to do is I'm going everywhere I see integer, because that's the thing. We want to make the same class, but we want the type to keep changing. And it's going to be a lot of work to do the cut and paste and keep changing it. Wouldn't it be nice if we could just write it once?
Yeah, that's
So how would you, if you were designing,
explain it, but
if you were designing the language, that's what you want to do. You want to be able to write this class once and have it be valid for every type that can be. So we'll take out the particular type, and again, this is the convention for declaring a type is to have a greater than, less than, and between it say the type. So let me just do this for now. Let's make sure we get all the integers. String. Now this is, whatever the type is, we're going to convert it into string, so we'll leave that alone. And the fields themselves are not, the first and the second are not integers, they are whatever the type is. So now what we have, so now what you're trying to do here is you're trying to put in something
that you can change.
that you can then say, let this be. So what would you put there? Would you put float? You don't want to put something concrete like float or integer, because it's the thing we want to change. We want to put something in here.
Object?
That's a good, that's a, what we were just talking about. Okay, this is a good idea. Suppose we made these of type object. That would be good, because now now we can make, we could then start, we could create pair items, and we could put anything, we could put strings, we could put floats, we could put anything into them because they're objects, so they'll accept it because everything derives from objects. But then we'll get into the thing we started at the beginning of this talk about, that the runtime, the compile time environment couldn't tell that a string was not the type. You know, like you put a string in and then you try to convert it to an integer, and then you'll have those problems. So what we decided to do was we could somehow say a type. In other words, we'll have like a type variable in here. A what? Like an identifier, so a letter, right? If you had to guess a letter, what letter would you pick? So there is no, you would just basically, if you think about it, you're randomly picking a letter, like A, right?
Right.
So what you could do you could do this. Now what did we just do? We just said,
Is there A as an int or as a...
well, A now is kind of like a variable. Think of it like a variable that holds a type.
Right.
Now, if somebody was to go and declare one of these, if somebody would say, I want to make a pair, they could go like this. And the object idea was a good idea, but because that would definitely, anything could be put into it. But then we couldn't get those compile time, we wouldn't know the types until it was runtime, when we try to convert it back. So that was definitely a good idea, but if somebody wanted to make a pair, they would say pair, what would they say? They would say pair P equals new pair.
Are you eating also?
But we want them to be able to say what it's a pair of. So they would actually go, we would allow them to do this. They can now say int pi equals new pair int, and then, right? We have a type called pair, but then we give two parameters that get filled in with these A's. So we're saying we have a pair of an integer to integer pair, and it's called pi, pair of integers. And then we say new and say the type again. So all we've really done is, we're used to seeing a class of type pair, and then you declare objects of that type. Now, because this class takes in a parameter for the type of the things it is, you supply it in this open paren, close paren. And what we can actually do, to be more generic, is, right now the way we did it, by picking the letter, putting A here and A here, it means that both items have to be of the same type. We can actually let them have more freedom, let them be of different types, by saying what? Now you have the idea with the letter A, B, right? If we made the second one a B, the first one is of type A, whatever the person wants it to be, and if they want to, they can make the second one a different thing. They can have an integer string pair, or a string integer, or a float integer, any combination there. So let's make sure we get the A's and the B's right. A here, B here. Get first would return an A. Get second would return a B. Converting them to strings, whatever they are, they'd get converted to strings and return as a string. The first one is of type A and the second one is of type B. Now what we've done is we've made a class called pair that has two types, that has parameterized two types. And now anyone can come along and say pair, integer, string. You could do anything. You could say pair, float int. We could do any combination of two. We could pair any two things together. Now we can still have them match. It could be float. A becomes of type float and B becomes of type float. But we gave ourselves more freedom by switching to A and B.
Where would you put that, commit that line of code?
This line?
Yeah.
This would be, later on in your program. So like, when we declare classes and then later on we start using them?
Right.
So we're now creating an object of type pair with a float on the left side and an integer on the right side. Now the technique he mentioned about having these all be objects, that would work. We could just instead of saying A and B in the smaller than greater than, we could have made this object. It would have worked. We wouldn't declare the types. We would just start stuffing floats and integers in. But then if someone came along, let's say you wanted these to be only float integer pairs. If someone came along and threw a string in, you're going to take it because you'll take anything. Now by putting these letters here and declaring the pair, the PI thing, well, I'd have to call it like PFI at this point, but You get the idea. So this would be, I could call the object, PFI, a pair of float and integer objects, and then, new pair float. At this point, if somebody tried to stuff a string into one of these, you're going to get a compile time error. So that's why spreading these things around gives us the opportunity to have better control over, people using our data structure. I kind of like the idea of starting with A, just going A, B, C. What most textbooks will use, and I don't know if this comes from, they always start off with the letter T is the first one. So this is just so you get, if you look on Google or you look through most textbooks, they generally, a lot of these parameterized, a lot of these classes you'll make may only have one type. So they generally use T. I don't know if that's T, I don't know if it's because it's the first letter of the word type, or this concept dates back to something in C++, they use a thing called templates. So I don't know if it's the first letter of the word template or the first letter of the word type, but it's generally, you'll just see it. Like I say, A and B would work fine. I think A and B is smarter because the next, if they generally, textbooks, if they have another letter to use, they usually go to S. I would think it would be T and then the letter after T, but for some reason they use S. So this example would generally show up in a textbook looking like this. But A and B, I like better because if we decide we need a third one, C is the next letter in the alphabet. It's perfect, right? Start with A and just go till you run out of letters. But they generally use T, and then if they start needing more, they generally use S after that, and then R, and who knows after that, TT or something like that. So I like starting with A and going from there. So that was a good a good guess to start with. But what we're really doing is we're parameterizing. It's kind of like we're turning T into a parameter. So when it's used, but it's a parameter for a type. So when you declare one of these objects, you have to specify the types. And the type will be specified in the constructor. So we could have had, more items. We can make a triple, not a pair. What would you call it? Three things. A triple, I guess. We could make a class called triple, and it would be A, B, and C. And then when someone declared one, they would say, a float, an integer, and a name. First name, last name, integer. And we can make objects that way. So what a generic is that it's used when you're declaring a class that is going to, generally it's when it contains something. But when you're declaring a class and the class itself could be used for many types, not just one type, it would be a pain to write the class for one type and then cut and paste it and keep changing the type everywhere. The only thing you're changing is the type. Everything else stays exactly the same. All the functions are exactly the same. The fields are exactly the same. It's a first and a second in this case. Everything is exactly the same. The only thing that's changing is the type. So what they decided to do, like I said, I think it was around 2004, they let you parameterize the type. So you and the way you parameterize the type is you have the less than and greater than with, and you just make up just like a character, just like a variable. You make up some letter, and then as long as that shows up everywhere in the class, people can use it like this. So what we could do, it probably makes more sense in a data structures class to then start going into all the different containers and their generics, what they're used for. But we could find one or two examples where maybe what we'll do, we could put up a simple example just using this array list. But this would show up in a data structures class in Java. This would show up a lot. And it's good because you don't have to code up the data structure. Somebody else already coded it up for you.